Students, this is the solution from the heat files, file A and file B from April 6th, which was due April 13th. So most of you turned this in. I'm very grateful, did a great job. You need to go back and check your own answers on these. Okay, so the problems were the Q equals MC delta T, one solving for Q, one solving for C, and one solving for delta T. And then the rest were heat of formation problems, heat of reaction. So here's the answer to 1, 2, and 3. 4 was exo, goes down. 5 was endo, goes up. 6 was endo because you're adding heat on the left, curve goes up. And exo, the number 7 was exo because heat is a product, it's released, so it's exothermic, goes down. And here were the heat of reaction problems for 8, 9, and 10. If you need to see this more, pause the video right now. Beep, beep, beep. Okay, so now the next question was on file B, defining boiling point, Le Chatelier, the phase diagram of water, whoops, and then the Q1 through 5 problem. And some of you, how did you know the Q1 through 5 problem? How did you know that? Because my old video from April 6th talked about the heat problems. So number 1, I'll let you read this, but I'll say it too. The boiling point of a liquid is the temperature at which the equilibrium vapor pressure of the liquid equals the atmospheric pressure. Now, what do you mean by that? So I'm going to bring up that phase diagram. I'm just going to bring it up here. What that means is, and if you've watched those other videos, this is a repeat of that, but when you heat up a gas, it raises, on this phase diagram, raises the pressure. And if it is when you raise that past 1 atmosphere, now for Canadian, we're at less elevation, so we have less air above us. So we're a little bit lower. We're not 100 Celsius boiling. We're like 95, 96, 97, depending on the pressure. And some of you know about a pressure cooker. Your mom puts this pressure cooker on and she puts a lid on it and there's a little valve. And if when you raise the pressure, it raises the temperature. There's more MC delta T, more heat. It cooks food faster. And you probably saw that in some of the videos. So I'll continue there. Okay, so that's boiling point. And I will show a demonstration where I will boil water with my hand. I will show that demonstration later. Okay, number 2, Le Chatelier. And if you Googled it, great. If you didn't, I think this was one of my students, and I think they got it from a previous student from last year because it was a good definition that I used last year. A system will remain at equilibrium until something happens to change its condition. If the system at equilibrium is stressed, it will shift to reduce the stress. And I'll spend more time talking about Le Chatelier in a video, and I'll add that video to our site. So what do you mean? If you add, like this equation right here, see it? Water plus heat yields water gas. In other words, when I heat up a liquid, it turns into a gas, and you can reverse it. You can reverse it. It's a reversible reaction, kind of like charging a battery and using a battery. So if you add something to the left, if you add heat, it's going to shift to the right. That's that trying to reduce the stress. And I can't show it with my hands, but we'll talk about it later, especially if you take Chem 2. So pause the video and look at all the other ways to change equilibrium. Beep. There we go. Okay, here's the phase diagram. We've already talked about it. This is the triple point. This is the critical point. And this is the normal boiling point right here, 100 Celsius. Here's the Q1 through 5 problem. And how did you know to do this problem? It was on the try this one back in the April 6th video about Q1 through 5. So going from negative 10 Celsius to 188 Celsius, 72 grams, take 72 times 1 mole over 18 grams equals 4 moles. Why do you need that one for the kilojoules per mole problem? So I'll just pause here and you can see the MC delta T for these places here, Q1, 3, and 5, Q2 and 4 are the number of moles times the kilojoules per mole, which you kind of saw in the heat of reaction problems, didn't you? And if you add up all the, this is actually supposed to be kilojoules. This was Jackie, and I'm not ragging on Jackie, but I missed it too. That's supposed to be a kilojoule. These are all kilojoules in boxes, so it's 230.63 kilojoules. I started writing this down and I thought, wait a second, Jackie already had it done, except for the kilojoule. That's okay. That was very good. Okay, so this was the answers to the April 6th file A and file B problems, and we'll talk more about them later. Thanks.